Welcome to simultaneous equations using the elimination method. When we solve equations that have two variables, one method we can use is the elimination method. This involves adding the equations or subtracting the equations so that one variable disappears, eliminates. This may require you to multiply one or both equations by a constant. Once you've eliminated one of the variables, you then solve the equation and then you find the value of the other variable through substitution. Let's have a look at some examples. So, example 1. Solve 2x plus y equals 4, 3x minus y equals 1. Now, a reminder from our previous video that there is only one set of solutions that works for x and y and works for both equations. So let's have a look at this. So if we add the equations together, so let's add the x's first. 2x plus 3x gets us 5x. Adding the y's, y minus y eliminates the y's. And 4 plus 1 gives us 5. Solving for x, we divide both sides by 5 and we get x equals 1. So if we substitute x equals 1 into the first equation to solve for y, we get 2 lots of 1 plus y equals 4. That's 2 plus y equals 4. So subtracting both sides by 2 gives us y equals 2. So x equals 1 and y equals 2 are our two solutions, is our solution. Let's check with the second equation that that's actually correct. So 3 times 1 is 3 minus, well, y is 2, so 3 minus 2 equals 1. So you can see that one solution, x equals 1, y equals 2, is the solution for both equations. Second example, solve the following. 3x plus y equals 8, x plus y equals 4. So if we subtract the equations, on this occasion, the x's, 3x minus x is 2x, and y minus y eliminates. And 8 minus 4 equals 4. So 2x equals 4. And we solve that equation, giving us x equals 2. Substitute x equals 2 into the first equation to solve for y, and we get 3 times 2 is 6. 6 plus y equals 8. Subtracting the 6, we get y equals 2. So the solution for this set of simultaneous equations is x equals 2 and y equals 2. Now for our third example. In this example, notice that if we were to add the two equations, we get 4x plus 3y equals 17. So we haven't eliminated either of the variables. Try subtracting. So we get 2x plus y equals 9. And once again, we haven't eliminated. So this requires us to do what the next method, which is to multiply one of the equations, sometimes both. But in this case, we're just going to multiply the second equation to make either the x's or the y their coefficient equivalent in both equations. So in this one, we're going to multiply the second equation by 2. So the x plus y equals 4. If we double everything, we get 2x plus 2y equals 8. And you'll notice that now we have the y coefficients the same. So we can either add or subtract. Subtracting allows us to eliminate the y's. So 3x minus 2x is x. 2y minus 2y eliminates. 13 minus 8 is 5. So now we substitute x equals 5 into the first equation to solve for y. So 3 5s are 15 plus the 2y equals 13. Subtract the 15 from both sides. And we get 2y equals minus 2. Dividing by 2 gives us y equals to minus 1. So for this set of simultaneous equations, x equals 5 and y equals minus 1 is the solution. So as a recap, when we use the elimination method, we can either add or subtract the equations and one variable will disappear. If this doesn't happen, you may be required to multiply one or both of the equations by a constant. Once you've eliminated one of the variables, you solve the equation for the variable that's left, and then you find the value of the other variable through substitution. Thank you.